All right, we are looking at A71, and we're actually just focusing on the zero product property to break these things down. So the zero product property is what says if I have two things that multiply together and my product is zero, then either A equals 0 or B equals 0. So what I want you to understand is these are already factored. You already have something times something equals 0. So the question is, what would make the final outcome 0? What would make this side 0? And so if you look at this, what would make x minus 2? What would make, what's in this parentheses? 2. So x could be 2, and here's why. 2 minus 2 is what? 0. And if I take 0 and distribute it, it wipes it out. That's all we're doing. What would make this 0 if x was 3? So that's what's going on your line. X equals 2, x equals 3. You can put an or there, you can put a comma, I'll even take the word and. Bless you. Now, what are we really doing? I know you guys can look at this and tell me x is negative 5. Do we agree that you can tell me that without much effort? Yeah. Okay, but sometimes you have to put more effort in. So what am I doing? I'm taking what's in parentheses, this set right here, and setting it equal to 0. Then what would I do? Subtract 5 from both sides, and there's my answer. X equals negative 5. So the idea is we can look at this, say negative 5 plus 5 is 0. But what I'm really doing is setting this equal to 0 and solving. So x equals negative 5 is one outcome. What's the other outcome? X equals negative 3. Okay, and what's different about the third one here? So in this one, you just have an x and you have an x minus 1. So what could make this 0? This part here, right here. If x was 0. Because if I replace this x with 0, it wipes it all out. What would make this 0? If x is 1. Okay, so x is, you could even write it like this. X equals 0, 1. Okay, now here's the deal. Let's talk about this. I'm really not happy about 4 and 5 because if you turn this in for factoring, you wouldn't get full credit. Why would you not get full credit on number 4? Well, it's real. It's in front of me. It's tangible. It's a thing. It's not an imaginary number.
Express that without letters.
So here's the deal. Do you see that there's still a GCF left in there?
Yeah.
So essentially, if we finish factoring this, this would be a 2, and what would be left? X minus 1. And what about this right here?
X minus 3.
Well, what do these both have in common?
3.
A 3. So it's still times 3. And if I divide both of these by 3, what's left? X plus 1. So if we were cleaning this up, we would take the 2 times 3 and say, hey, that's 6. And then this multiplies to be x minus 1 and x plus 1. So I just wanted to go over this because honestly, if this was your factored answer, this is the final factoring. Now looking at this, what would make this 0 if x was positive 1 or negative 1? The other way you might see this answer written is x equals plus or minus 1. I'll accept either one. Okay, now, if I didn't have it fully factored, so we see that number 5 is not fully factored. What do these still have in common? They still have a 3. But let's not worry about that. We'll get the same answer. We have three pieces. We have a 2 times an x times this chunk. So 2 will always be 2, but x could be what? 0. And 2 times 0 would make everything 0. What would make this 0? We'll make that 0.
Positive 2.
Where'd you get that from?
Well, 6 and then the 3.
All right, so you were right with the positive 2. What we're really doing is we're taking 3x minus 6 setting equal to 0. You would add the 6 over to solve it. And you would get 3x equals 6 and then divide both sides by 2. Or 3, sorry, to get out 2. Now some of you could see it. Oh, 3 times 2 is 6. 6 minus 6 is 0. So these are my 2 answers. Go ahead. I'm going to let you do the next couple, and then we'll talk about them.
What do you mean by the next couple?
Like 6 through 8. Do these next 3. So the next few. All right, so let's look at this. This one is just x minus 5, so I can look at this and tell you, hey, x could be 5. Because 5 minus 5 is 0. I think a lot of people are ignoring this and they see +5, so they say x can be -5. But that negative sign also means we don't want x to be 5. If I took this off to the side, -x plus 5 equals 0, I would subtract 5, and then I would divide by -1. So both outcomes are both +5. So even though it's a quadratic, like if we FOIL this, we get that -x squared. Sometimes I only get one answer. This is one of those examples where the quadratic, and I'm not graphing this accurately, but the quadratic would bounce off the x-axis. You'd have one solution, where these are problems where the quadratic would go through and have two x-intercepts, if you remember back to graphing. Okay, x would be 0, or x would be what? -8. That's it. That's all you're doing. So honestly, factoring's the hard part. Now, this one has 3 pieces. So x could be 0. Okay, I see that. Right?
Yep.
What would this one be? The whole thing. It'd be 1/2. Why? Because I would set 2x minus 1 equal to 0, and then I would add 1 and get 2x is 1. Divide both sides by 2, and there's my 1/2. All right, so if you didn't catch number 8, take a minute and do the last part of 8, and go ahead and do 9 and 10 real quick. So try these. So 3x plus 9 equals 0. We are going to subtract the 9, divide both sides by 3, and I get x equals -3 as my third answer. Okay, this is the one I can do really quickly in my head. X is -2. This is the one that some of us can do in our head, and we know it's x equals -1/3. Where did I get that? I took the time in my brain and I envisioned, hey, I'm going to subtract 1. That's where I got the negative. And once I subtract 1, I would divide by what? Divide by -3. All right, what would be the answer for this one? If you need to see it, take that 2x minus 1 equal to 0. Add 1. That's why we get the sign change. Divide by 2, and I get 1/2, -1/3, and -2. All right, last one. Whew, fractions. X is 0. I got that one. All right, now, we could probably do this in our heads, but if we wanted to, we could write it down. We could even get our little calculators out. I would subtract 4 first, and then how do I get rid of that 1/2? Well, you would divide because of multiplication. Here's my problem. A lot of us are going to tell me the answer is -4, but it's really what?
-8.
It's -8, folks. So I don't.
Wait, actually?
It actually is. Glad you surprised yourself. When you
I need a doctor.
when you divide by a fraction, think about. I know it's negative, but think about $4. How many half dollars are in $4? 8, right?
Oh,
2
wow.
for every dollar. But most of us just see 4 and we see a half, so we want to say 2. So I'm asking you, instead of, you would either put this in the calculator to get it right, or instead of dividing by a fraction, you multiply by the, what's it called when you flip a fraction?
Numerator?
Now I'm going to go with reciprocal, but thanks for playing. And then I get -4 times 2, and there's my -8. So I've got my 0, I've got my -8. And now that we're going to get it right, what would this answer be? 1/4 x minus 3 equals 0. What would I do? I would add 3, and I could divide by 4, and maybe you know that I would get 12. If not, I would multiply by the what? What was that term? The reciprocal. And I don't have to think, and I don't need my calculator. X equals 12. Okay, so are we all, what tornado? Those are not tornadoes. Do you understand that this was already pre-factored for us, and then we just had to look at what would make them zeros?